So this is the May 2019 non-calculator paper for the foundation tier. So this is up to a grade 5. If you're doing foundation, have a go at the paper, watch along and see if you can get the questions correct. Pause it, have a go, and then watch or do it along with me. So the first question is to write 180 minutes in hours. Now we know that 1 hour is equal to 60 minutes. So if I was going from hours to minutes, I would multiply by 60. If I was going from minutes to hours, I would divide by 60. So we're going to do 180 divided by 60, which goes in 3 times. So you can do 60, 120, 180. So it's 3 hours. For question number 2, we're asked to write 0.73 as a percentage. Now 0.73 is the number 73 that's been moved 2 columns to the right. If we divided it by 10, it would become 7.3. If we divide it by 100, it becomes 0.73. So the easiest way to do this is to say that it's 73 that's been divided by 100, and that is 73 out of 100. And now we know that it's out of 100, so is percentage. So this is equal to 73%. Question number 3, work out 10 times 3 add 5. Now BidMaths tells us to calculate the bracket part first. 3 add 5 is 8. So this is 10 times 8, which is 80. So remember, BidMaths is brackets, indices, divide and multiply, they should be on the same level. Add and subtract, they should be on the same level as well. Write down a prime number that's between 20 and 30. So prime numbers are numbers that can only be divided by themselves and 1 an exact number of times. So only 1 and themselves are factors, so they have 2 factors. So 21 is not a prime number because it's in the 3 times table. 22 is in the 2 times table, so that's no good. 23 isn't in any times table other than 1 and 23. So that is a prime number, so we can have that one. 24 is in the 2 times table, it's no good. 25 is in the 5 times table, so that's no good. 26 is in the 2 times table. 27 is in the 3 times table and the 9 times table. 28 is in the 2 times table, and 29 is only in the 1 and the 29 times table, so that one's also prime. And then we can't have 20 or 30 because it's not in between. So you could put 23 or 29 for that question. I'm just going to put 23 because we don't need to put both. It just says a prime number. We just want to put 1. Well done if you got that. Find the number that is exactly halfway between 7 and 15. So we could write out the numbers 7, 8, 9, 10, 11, 12, 13, 14, 15 and just go halfway. But there's an easier way. If you ever want to go in between 2 numbers, you can find the average. And to do that, we would add them together and divide by 2. So 7 add 15 is 22. And if we divide that by 2, we get 11. So that's much, much quicker, but nothing wrong with writing them out and just crossing off each end and getting to the middle number. So either way, the answer for that one is 11, but much easier to add them together and divide by 2. Question number 6. Harry is planning a holiday for 4 people for 7 days. Here are the costs for the holiday for each person. So the travel's £150, the hotel is £50 for each day, and spending money is £250. Work out the total cost of the holiday for 4 people for 7 days. So the travel is £150. It doesn't matter how many days you're going for, the travel's going to be £150 per person. So we can put that down there. The hotel is £50 for each day, and we're going for 7 days. So we can't just add on 50, we need to do 50 times 7. To work out the total cost of the hotel for the 7 days that we're there. So 7 times 0 is 0, and 7 times 5 is 35, so that would be £350. So let's add that on to our costs. And then spending money is £250, and that's for the whole time that we're there. Adding that together, 0 add 0 add 0 is 0, 5 add 5 add 5 is 15, so 5 carry the 1. 1 add 3 add 2, 1, 2, 3, 4, 5, 6, and then that extra 1 makes 7. So that is £750 per person. So I then want to do 750 multiplied by the 4 because they've asked me for the total cost for all 4 people. And you could of course do 750, add 750, add 750, add 750, but easier to multiply. So 4 times 0 is 0. 4 times 5 is 20. So 0 here, carry the 2. And 4 times 7 is 28. Add the 2 is 30. So that is £3,000. And that's our final answer. That is the cost for the holiday for 4 people. So let's just pop that on the answer line. In Adam's garden, the flowers are only red or white or yellow or blue. The chart shows the number of red flowers, the number of white flowers, and the number of yellow flowers. So we've got the number of flowers up the side here on our y-axis, and we've got the different colours along the x-axis. So the total number of flowers is 30. Work out the number of blue flowers. So red, we can see that that goes up to 8, so we've got 8 red flowers. For white, we've got 10, and for yellow, we've got 5. Now if I do 8, add 10, add 5, 8 add 5 is 13, carry the 1. 1 add 1 is 2. So we can see that's 23 flowers so far. If the total number of flowers is 30, 30 take away 23 is 7. So work out the number of blue flowers, it must be 7 because there's no other colour flowers there. We've got 3 of them in the table and the last colour is blue and there aren't any others, so it must be 7. Write down the mode. Now the mode means the most common. So the most common colour of flower would be the one with the highest frequency, and that just means how many there are frequency. So we're looking for the one with the highest frequency. We know that there are 7 blue flowers, but we could see that actually the mode in this case is going to be white because white is the highest frequency. It's the most of the flowers are white rather than anything else. So the mode is white. Number 8, write down the following fractions in order of size. Start with the smallest fraction. So it's important to remember for this question that this is a non-calculator paper. If we had a calculator, we might do 1 divided by 3, 3 divided by 4, and so on to get the decimal values. But here we need to work without a calculator. So we're going to do that by making all of the denominators, the bottom numbers, the same. So I'm going to make all of these fractions out of 12. Now the reason I've picked 12 is because 12 is in the 3 times table, it's in the 4 times table, it's in the 12 times table, and it's in the 2 times table. So it's nice and easy for me to multiply each of these fractions on the bottom and the top to get an equivalent fraction that is out of 12. So this first fraction is a 3 on the denominator. We need to multiply that by 4 on the bottom and the top to make it out of 12. So we've done the 3 times 4 for the bottom number, and we also need to times the top by 4, and that is 4. For the next one, I need to times it by 3, top and bottom, to get an equivalent fraction. So I also need to times the top by 3, and 3 times 3 is 9. For the next one, again, I need to times it by 3, top and bottom, and that is 3 over 12. I've times the bottom by 3, I've also times the top by 3. This one's already out of 12, so that's great, we can just leave that one as it is. And for the last one, to make it out of 12, I've multiplied by 6 on the bottom, because 2 times 6 is 12, so I also need to times the top by 6, and that is 6 over 12. And now it's nice and straightforward for us to see which one's the smallest. 3 out of 12 is the smallest, so I'm going to put a quarter first, because that's the original format. Then 4 out of 12, which is a third. Then 6 out of 12, which is a half. And then 7 out of 12, which was how it was in the original question. And then 3 quarters. Always check 1, 2, 3, 4, 5 in the question, 1, 2, 3, 4, 5 in the answer. So that's how we would do that one. Ruth left her home at 9 a.m. and walked to the library. She got to the library at 10:30. Ruth walked at a speed of 4 miles per hour. Work out the distance that Ruth walked. So for this, we need to remember that if we're ever talking about speed, we need to draw that triangle. So we've got speed, distance, time. And then we cover up the thing we want to know. Now in this case, we're being asked for the distance. And if we cover up distance, we're left with S and T, which are next to each other. And that means that we multiply them together. So we're going to do the speed multiplied by the time. Now I've got the speed, it's 4. But the time, I don't currently have. But I do know that it took her from 9 a.m. until 10:30 a.m., which is 1 hour and 30 minutes. Now that is 1.5. We can't put 1.3. It's not 0.3 of an hour. It's 0.5 of an hour. It's an hour and a half. So 1 hour and half an hour. So 1.5. So we're going to multiply 4 by 1.5. And that means we're going to times it by 2 and times it by 2 again. Or you can do 1.5 times 4 like this. 4 times 5 is 20, so 0, carry the 2. And 4 times 1 is 4, add the 2 is 6. And the point there, one number after the decimal point in the question, means one number after the decimal point in the answer. So 6.0 or 6 miles. Okay, part B. Ruth got to the library at 10:30 a.m. She stayed at the library for 50 minutes and then she walked home. Ruth took an hour and a quarter to get home. At what time did Ruth get home? So 10:30, we need to add on 50 minutes first. That's how long she stayed at the library. Now it would take you 30 minutes to get to 11 a.m. And we'd then have another 20 minutes to add on. So I always like to do in jumps, go to the hour and then do the next bit. So that takes us up to 11:20. Then she took an hour and a quarter to get home. So an hour and a quarter, let's add the hour on first. So we're at 11:20 now. Let's add on the hour. And that is 12:20. And then we've just got to add on the quarter of an hour. Now a quarter of an hour is 15 minutes. So adding on 15 minutes takes us up to 12:35 p.m. Good. Ooh, 12:35. Great. Okay, onto the algebra page, which is my favourite. So 10a, solve t, add t is 12. Now you might choose to write that as 3t equals 12. When we add algebra like that, t, add t, we say that that is 3 lots of t, so 3t. And then what do we need to do to both sides to get the t on its own? So when we're solving, we're always looking to get that letter on its own. So if we divide this side by 3, and we divide this side by 3, we'll just get 1 lot of t, and that equals 4. And that makes sense because 4 add 4 does make 12, and they'd all have to be the same number because they're using the same letter. So t equals 4. For the next one, when I'm solving equations, I like to do a dotted line, and then what I'm doing on one side of that dotted line, I'm also doing on the other. So the dotted line goes where the equals sign is. So on this side, on the left, I just want x to be on its own. I always, when I'm solving, just want that letter to be on its own. What's annoying me at the minute is that I've got a -2. How could we get rid of -2? Now, the only way to get rid of -2 is to add 2. And as long as I add 2 to this side, I also need to add 2 to this side. So I've now got x on its own on the left. We've added 2, which has cancelled out that bit. And I've added 2 on the right, so x is equal to 8. And that makes sense because 8 take away 2 is 6. So x is 8. Same for this bottom one. I want to try and get that w on its own. Now w is being multiplied by 6, and then we're adding 2. So we need to undo that in reverse order. Let's take away 2 from both sides first, and that's going to get rid of the +2. So that's going to cancel that out, and that leaves us with 6w equals 18. I've taken away 2 from the left-hand side to get rid of the +2, so I've also taken away 2 from the right-hand side. Now, if 6 lots of w equals 18, this is a multiplication here that's connecting these two things. So I'm going to divide this side by 6 because that will separate those and we'll just get 1 lot of w. And on the right-hand side, we need to do the same. So 18 divided by 6 is 3. So that's our answer for that one. And we can always put it back in and check. 6 times 3 is 18, add 2 makes 20, so we know we've got the right answer. Question 11, work out 74 times 58. Now this is a classic non-calculator question. You need to be prepared for if they ask you to multiply numbers or decimals. If it was 7.4 times 5.8, we'd be doing this in exactly the same way. We'd just put the decimal point back in at the end. So 74 times 58 without a calculator. So if you have learnt the traditional method, in primary school you were probably taught to do something like this. Now I love this method is great. If you are confident with this method, great, go for it. However, if you've reached year 9, year 10, year 11, or just secondary school probably in general, and you're not confident with this method, then I would use something called Napier's bones. It's got lots of different names, but it involves drawing boxes. and you draw 2 boxes across because 74 has 2 digits, and you draw 2 boxes going down because 58 has 2 digits. If it was a 3-digit number like 132, then I would make this wider this way and make sure I had 3 boxes going across, but it doesn't. Now each box needs to be split diagonally. I like to just do each box at a time because then you're not going to go wrong with the longer diagonal ones, and then just make them a little bit longer on the edges like that. Okay, cool. So let's go back to the traditional first method. We're going to start with the 8. Now 8 times 4 is 32. So I'm going to put 2 here, carry the 3, and 8 times 7 is 56. Add that 3 is 59. We're done with the 8. Now moving over to the 5. 5 times 4. Oh, first put in your 0 because we're going to treat it like a 5, but actually it's 50. Now 5 times 4 is 20, so 0 down, carry the 2. And then 5 times 7 is 35, add that 2 is 37. And then we're going to add that together. 2 add 0 is 2, 9 add 0 is 9, 5 add 7 is 12, carry the 1, 3 add 1 is 4. So my answer would be 4,292. Now that method is great, but I would say as an examiner, I see that question go wrong, that method, go wrong more often because you're having to hold a lot more information in your head when you're carrying those numbers and things and adding them on. There's a lot more holding in your head for that one. So for this method on the right, 4 times 5, so I'm doing a number at the top times the number at the side. 4 times 5 is 20, so I put 2, 0 in that little box there. Then underneath I've got 4 times 8, which is 32. Over here in this box, I'm doing 7, because that's the number at the top, times 5, because that's the number at the side, 35. And then 7 times 8 is 56. If you had a number less than 10, if the answer was less than 10, you'd put 0, and then you'd put, let's say it was 8, you'd put 0, 8 in the box like that. So that's how you'd do it if it was less than 10, but we didn't have any numbers less than 10 there, so that's fine. Now we're going to add down each diagonal section. So in this first diagonal section, you've just got 2. In the next diagonal section, you've got 6 add 3 add 0, which is 9. In the next diagonal section, we've got 5 add 5 add 2, which is 12. So we put 2, carry the 1, and then I've got 3 add 1 in that top section, which makes 4. So again, we get 4,292. And in a GCSE, there's nothing wrong with doing both ways. Check you get the same answer, and then confidently put that answer on the answer line. If the question had have been 7.4 times 5.8, you would go down with 1 decimal point and across with the other until they meet, and then you go down that diagonal, and that tells you where to put the decimal point. So it's a really good method, this one, for multiplying decimals as well. Obviously that wasn't the question here, so the answer is just 4,292. AB and BC are perpendicular lines. Find the value of x. So AB is just the line that goes from A to B. It's just how we say a line, and BC is just the line that goes from B to C, and they're saying they're perpendicular. Now if 2 lines are perpendicular, it means there is 90 degrees between them. So we know that all of the angles around this bit need to add up to 90. Now I've got 25 so far and another 25. 25 add 25, 5 add 5 is 10, and 2 add 2 add 1 is 5. So we've got 50 degrees so far. So I then just want to do 90, take away the 50 that we've already got. 0 take 0 is 0, 9 take 5 is 4. So I've got 40 degrees. That must be the value of x, so that all 3 of them together add up to make 90. Cool. RS and TU are parallel lines. PQ is a straight line. So RS, that's this one, and TU, that's this one, are parallel lines. And parallel lines are shown with those arrows. You can see them there and there. And then PQ is a straight line going the other way. You can see that going across. An angle of size 125 is shown on the diagram. Write down the letter of one other angle of size 125. Now you've got a few choices here, but we've got to give a reason for our answer, and it must match up with the one that you say. So for example, if I said B, I could say B equals 125 degrees because opposite angles are equal. So if 2 angles are opposite each other and they're making that X shape like that, then the ones that are opposite are going to be equal. So because opposite angles are equal, that's one correct answer. But you could also say D, because this angle up here and this angle up here are corresponding. So they make that F shape. If you go round this angle and you go round this angle, they make that F shape. Now, admittedly, that F is very much upside down and back to front, but hopefully you can see that you could slide this angle down onto that one, and that means that they're corresponding. Now, I have a bit of a stupid way of remembering it, and that is alternate and corresponding, and that's because that Z shape is an alternate angle, corresponding. Obviously, don't write corresponding on your actual exam, but you can remember that the F shape is corresponding, if that makes any sense. So you could also say D equals 125 because corresponding angles are equal. Nothing wrong with that. Equal, there we go. Cool, and then it says explain why A add B add C is 235. So A add B add C would be adding all of these angles together here. And we know that angles around a point add up to 360. So I've obviously done 360, take away 125, and that leaves you with, okay, so let's do this. More on the floor here, borrow from next door, so that becomes a 5. 10 take 5 is 5. 5 take 2 is 3, 3 take 1 is 2, 235. So the reason would be that angles around a point add up to 360 degrees. And what we don't want to see as examiners is you saying, because they've done 235, add 125, and that makes 360. We don't want to know why, we don't want to know the process, we want to know the reason. So angles around a point add to 360, and that working there shows us everything that we need. So that's a 1 mark question, and we would need to see that sentence to get that mark. Question 13, the length of a line is x centimetres. Write down an expression in terms of x for the length of the line in millimetres. So a lot of people would see this question and just freak out because there's no numbers and there's algebra, which always makes people a little bit worried about what it's going to be. So the length of the line is x centimetres. Now I'm going to change this question and just say, let's just call it 5 centimetres, because if it's scary because there are no numbers, just imagine there are some numbers and see what you would do. So write down an expression for the length of the line in millimetres. Now we know that 1 centimetre is 10 millimetres. And if you didn't know that, I would urge you to get a ruler that has centimetres on one side and millimetres on the other, because then you can see how many millimetres are making up a centimetre. So, and that's most rulers to be fair. 1 centimetre is 10 millimetres. So to get from centimetres to millimetres, what do we need to do? Well, we need to times by 10 if we were going that way. If we were going from millimetres to centimetres, we would divide by 10. Now, in this case, 5 centimetres would be 50 millimetres because we would times it by 10 to go from centimetres to millimetres. So it kind of doesn't matter what the number is. We can see that if we were going from centimetres to millimetres, we would times by 10. So if I've got x centimetres and I want to get it into millimetres, I need to times by 10. So it's going to be x times 10. How do we write that? Well, we write 10x. Quite tricky, that one. Hopefully that makes sense. Question 14, work out a fifth of 70. So for a fraction of an amount, we're going to divide by the bottom and then times by the top. So 70 divided by 5 and then times that answer by 1. Now 70 divided by 5, I'm going to use my bus stop method. 70 divided by 5. How many 5s fit into 70? It fits one whole number of times with 2 left over. How many 5s go into 20? It fits 4 times, no remainder, so that's 14. So we're dividing by the bottom, and then the answer that we're getting, we're timesing by the top. But in this case, we're just timesing it by 1, which keeps it the same, so that's 14. For part B, Fiona has to work out the exact value of 48 divided by a half. She writes 48 divided by half is 24. Fiona's reason is there are 2 halves in 1, so there'll be 24 halves in 48. Explain what is wrong with Fiona's reason. Now, if I gave you 48 pieces of paper and I asked you to divide each of them into halves, you would end up with double the number of pieces of paper. You'd actually end up with 96 pieces of paper. So actually, when you divide by a half, you get double as much. So dividing by a half is the same as doubling. She's actually timesed by a half there. Doubling. Dividing by a half is the same as doubling. So yeah, no good, Fiona, sorry. Write down the value of the square root of 64. So that funny little tick thing, that means square root. So we're looking for a number that when we square it, we times it by itself, makes 64. So we are looking for something times something that makes 64. And both of those numbers need to be the same. So something times something that makes 64, and that would be 8. So 8 times 8 is 64. Yes, you could do 32 times 2, or you could do 16 times 4, but 8 times 8, because both of those numbers are the same, so 8 squared is equal to 64. So the squared and the square root sign, they're the opposite of each other. So 8 would be our answer, because 8 times 8 makes 64. And then it says work out the value of 5 cubed. Now I think this has come up on every single non-calculator paper where we've had to either square something or cube something. So we're showing that we understand what that little power number means. And it means you times it by itself that number of times. So if it was a little 2, we'd just do 5 times by itself, so 5 times 5. But because it's a little 3, that means we need to do 5 times 5 times 5, 3 times. Now 5 times 5 is 25, and then we need to times that by 5. So 25 times by 5, 5 times 5 is 25, and 5 times 2 is 10, add the 2 is 12. So 125 would be my answer there. Equally, if I asked you for the cube root of 125, that would be 5, because you're saying what number times by itself, times by itself, times by itself, or times by itself, times by itself, sorry, is equal to 125, and that would be 5. So this symbol is the inverse of this symbol. Wonderful. Question 16. We're going to expand brackets and then we're going to factorise brackets. So again, I love this topic because it looks the same every year. If you can practice it, you'll know what to do. So expand 5 lots of 2m minus 3. This means that everything in the bracket is being multiplied by 5. We're saying 5 lots of this bracket. And expand just means get rid of the brackets. So we're going to do 5 multiplied by the first thing and 5 multiplied by the second thing. And then everything in the brackets has been multiplied by 5. So 5 times 2m is 10m, because the 5 times 2 bit makes 10, and then we can just put an m next to it to show that it's multiplying. And then 5 times minus 3 is minus 15, or you can just do 5 times 3 and put the minus in the middle. But either way, we should get 10m minus 15, and that's our final answer. You can't do the actual take away 15. You can't actually do 10 take away 15 because they're not like terms. So if we've got m's on one bit and just normal numbers on the other bit, then you can't put them together any more than that. We just have to leave that as our answer. Now factorise means put into brackets. So we're kind of going opposite with this bottom bit. We're saying what could the brackets be that would expand out to give that answer. So first thing we need to do is say what have they got in common? Well, they're both in the 3 times table. There aren't any letters in common, but you could take a letter outside as well if you wanted to, if you could. So they're both in the 3 times table. So 3 goes on the outside, and then we're going to open our brackets. What would need to go in those brackets to make 3n add 12? So it'd be 3 times something to make 3n. So that means we need to put an n here. And then 3 times something to make plus 12, so that's going to be plus 4. And we could double check it by timesing out the brackets. 3 times n is 3n, and 3 times 4 is 12. So that's the inverse of what we did in part A, and the answer would be 3 lots of n add 4. So to factorise means to put it into brackets. Question 17. Stuart throws a biased coin 10 times. He gets 7 tails. So biased means it's not fair. So we would expect a coin to land on heads and tails the same number of times. If a coin is biased, it might not do that. It might land on heads or land on tails more times. Maxine throws the same coin 50 times and she gets 30 tails. Prasha is going to throw the coin once. Whose results will give the better estimate for the probability that she'll get tails, Stuart's or Maxine's? You must give a reason for your answer. So with data, the more times you do something, the more accurate the results are. If I flip a coin once and it lands on heads, I can't say it will land on heads every time. I've not done it enough times to know. So we would use Maxine's because she did more trials or because she did it more times. That would be absolutely fine. The more times you do it, the more accurate the results. So use Stuart's and Maxine's results to work out an estimate for the probability that Prasha will get tails. So yes, Maxine did it 50 times, which is great, but Stuart did it 10 times. So to get the most accurate results, we could just look at both of their data. So in total, they threw it 60 times. So we could put 60 as our denominator, because that's how many times they've done it. and Stuart got 7 tails, and Maxine got 30 tails. So altogether, it landed on tails 37 times out of 60. So that would be our answer. We've done 30 add 7 to get 37. That's how many times it landed on tails, out of the total, which was 10 add 50, so out of 60 times. That would be the probability that Prussia would get tails. We've used the data that they've given us so far to get 37 out of 60. The diagram shows a rectangular garden path. Wasim is going to cover the path with paving stones. Each paving stone is a square of side 30 centimetres. Each paving stone costs £2.50. Wasim has £220 to spend on paving stones. Show that he has enough money to buy all of the paving stones that he needs. So you could absolutely work out the area and divide it down, but I just like to personally see how many would fit going down like this and how many would fit going across, and then times the number of rows by the number of columns. So if each one is 30 centimetres in both directions, it's a square. How many 30s would fit into 120? So I'm going to do 120 divided by 30, and that is 4. 30, 60, 90, 120. So you could just count up until you got to what you needed, or you can divide it down, entirely up to you, but that fits in 4 times. So I'm going to fit 1, 2, 3, 4 rows of my paving slabs. Now looking at the other direction, I need to do 600 divided by 30. Now that's quite tricky to do, but I write it as a fraction for a reason, because you can just cancel it down. So I can divide the top by 10, divide the bottom by 10, and that is 60 over 3, and 60 divided by 3 is 20. So we would fit 20 columns going across like that. So I've got 20 columns times 4 rows, and that means that there would be 80 paving slabs. Each paving slab costs £2.50, so I need to do 80 times £2.50, and here's where that other method I think would come back in. So £2.50 has 3 digits and 80 has 2 digits, so I'm going to do £2.50 times 80, and I'm going to split every box into diagonal sections and make it a little bit longer at the bottom, somewhere to put my answer. 0 times 8 is 0. 0 times 0 is 0. 5 times 8 is 40, so we put 40 in that box. 5 times 0 is 0, so you're going to put 0, 0 in that box. 2 times 8 is 16, and 2 times 0 is 0. Now adding down the diagonal sections, I've just got 0, 0, 0, and then 6 add 4 is 10, so 0 carry the 1, and 1 add 1 is 2. And then you're going to go down with 1 decimal point, across with the other. Now this is 80, so the decimal point is there. Let me just change colour so that's easier to see. Let's go blue. So go down with this decimal point, across with this decimal point until they meet, and then you're going to go down that diagonal, so it's 200. 0.00, but we don't need the 0.00 here. So that is £200. £2.50 each. Perfect. So does he have enough? Yep. 220 is how much he's got to spend, and it costs £200. So we need to say yes, £200 is less than 220. He's definitely got enough. Question number 19a. Work out 2/3, take away 1/5. Again, another favourite on the non-calculator paper to ask you to add, subtract, multiply or divide fractions without a calculator. So if you're adding or subtracting fractions, we need to make the denominators the same. That's the bottom numbers. We've got a 3 on the denominator of one fraction, and we've got a 5 on the denominator on the other. So what's the number in the 3 times table and the 5 times table? It's going to make sense for this question to make both of these fractions out of 15. So the denominators need to be made the same. What have we done to this fraction to make it out of 15? We've times by 5. And again, we need to times the top by 5 to keep that fraction equivalent, and that is 10. On the second fraction, we've multiplied it by 3 to make the denominator 15, so I need to do the same to the top. 1 times 3 is 3, and now that the denominators are the same, I can do 10 take away 3, which is 7. So 7 out of 15 would be our answer. Always check that that can't be cancelled down, but here we've got no common factors of 7 and 15. They're not in the same times table for anything other than 1, so that would be our final answer. I will just show you the method that I quite like called the timesing TP. So for adding and subtracting, what you can always do, and again let's change colour pen here to blue, so let's do 3 times 5 is 15, and that goes on the bottom. 5 times 2, now I put an arrow on that for on purpose because 5 times 2 has to go here, which is 10. And then 3 times 1, which is 3, and that goes there. If it's a takeaway in the middle, you put that up here, and that gives you 7 over 15. So you might prefer that method. I call it the timesing TP because it makes that kind of like TP shape of like a tent. And you're timesing each of the lines where they go to. So 3 times 5 was that bottom number, 5 times 2, and 3 times 1. So that's a really good method. Again, that's only for adding and subtracting that you can do that. For part B, we're multiplying. So when you multiply fractions, this is the nicest one. This is definitely, we love a multiplication because all we have to do is 2 times 3 for the numerator, which is 6, and 3 times 4 for the denominator, which is 12. It says give your answer as a fraction in its simplest form. So we need to check that they're not in the same times tables. So they're both in the 6 times table. So the quickest way to simplify it would be to divide by 6 on the top and the bottom, and that is 1 over 2. You might have thought, oh, okay, I can halve them, which makes it 3 over 6, but then they're both in the 3 times table, so you'd want to go again, and that would be 1 over 2. So it doesn't matter if it takes you 2 steps, you just want to keep going until there are no more common factors. So that would be the answer to that one. Question number 20. Here are 2 squares A and B. The length of the side of square A is 50% of the length of the side of square B. Express the area of the shaded region of square A as a percentage of the area of square B. So I think a lot of students would look at this question and think, what on earth is going on? So let's just start by breaking it down. The length of the side of square A is 50%, so half of the length of the side of square length B. So that means that this length here is half of this square here. So I'm actually going to draw this inside this one. So I know that 2 of them would fit going that way and 2 of them would fit going that way. So one of them would fit there and it would look like that. One of them would fit there and it would look like that. One of them would fit there and one of them would fit there. So 4 of these would fit into this because 2 would fit going up and 2 would fit going across because it's half as big in both directions. So then it says express the area of the shaded region of square A as a percentage of the area of square B. So we can see that in this shape we've got 1 of those shaded bits, and in this shape we've got 4 of them. So I could join them together. I could put this bit, let's make it blue again, I could put this bit here and I could put this bit here, and I'd have no shading at the top anymore. So hopefully you can see that those could go together, and then how much of it would be shaded? Well, it would be half shaded, wouldn't it? Oh, wrong one. It would be half shaded, so we'd have 50% shaded, so the answer is 50%. That's the way it makes most sense in my head to draw it. So all of those would go together, the area of the shaded region of square A as a percentage of the area of square B, so 50% is our answer. There are 40 students in a class. Each student walks to school or cycles to school or gets the bus to school. There are 22 girls in the class, 9 of the girls walk to school, blah, 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 all the information. Right, this is either going to be a two-way table where you have students walking or cycling or getting the bus, or it's going to be a Venn diagram. Now, the way that you would tell the difference is, can they do more than one at the same time? So are they talking about people cycling and getting the bus, or are they talking about people walking and cycling? If so, it would be this, where they could be in both of the sections at the same time. But actually, not only are they talking about walking, cycling, or getting the bus, they're also talking about gender, girls and boys. So in this direction, we also want girls and boys, and they're not talking about people walking and cycling, for example, so there's no overlap. So this is just going to be in one category or the other, and that tells me that this topic is a two-way table where I have one set of data going in one direction and the other set of data going in the other direction. So let's draw that out properly and see what that would look like. And you don't have to draw it in the same order as me. You might have done a different order along the top, but ultimately your answer should be the same. This is why this one's a pain to mark, because everyone draws it differently. So we've got walking, we've got cycling, or we've got bus, and at the end we want to have the total. And then going in this direction, we've got girls, we've got boys, and again we've got the total down there. Okay, great. We know that there are 40 students, so I'm going to put 40 there in the total section because they tell me that in the question. There are 22 girls in the class, so the total for the girls would go at the end there, that's 22. 9 of the girls walk to school, so that would go in that box. 7 of the boys cycle to school. And 6 of the 10 students who get the bus, so 10 in total get the bus, and 6 of them are boys. And now we're just going to carry on filling in anything that we can. So the bus at the top here, that must be 4 girls, because 4 add 6 is how we would get 10. And hopefully you can see that if there are 22 girls in a class of 40 students, we would need 18 boys, because 40, take away 22, more on the floor, borrow from next door. 10 take 2 is 8, 3 take 2 is 1. So we've got 18 boys. So far we've got 7 boys cycling and 6 boys getting the bus, which is 13. So we need 5 more to make 18 for the total. And then we can tell that the total number of students walking to school is 14. That's actually all we need for the question, but I'm going to keep going just to make sure it's fully correct. I've got 14 here and 10 here. That makes 24. So I need another 16 cycling to add up to 40. And then 7 add what makes 16? Well, we would need another 9 students cycling, so that these two were adding together to make 16. And I'm then just going to check that my girls adds up to 22. So 9 add 4 is 18, add 4 is 22. So yep, that's fully correct, and now I'm confident that I've got it right. So we're looking, find the number of students that walk to school, and it is going to be 14. So let's just pop that down there on the answer line. 14 students. Question 22. There are only blue cubes, red cubes and yellow cubes in a box. The table shows the probability of taking at random a blue cube from the box. So we've got the colours blue, red, yellow. There are the only options. They've told us in the question that that's all you can get. And then we've got the probability underneath. Now we know that probability adds up to 1. So these are going to have to make 1. It says the number of red cubes in the box is the same as the number of yellow cubes. So we know that the probability of taking red and the probability of taking yellow would be the same. So I know that whatever goes here and whatever goes here needs to be the same number. Now if I do 1, take away 0.2, I've got 0.8 left. So I need both of these boxes, red and yellow, to add together to make 0.8, and they need to be the same. So 0.8 divided by 2 is 0.4. And always make sure they add up to make 1. Now if you didn't know that, just put 2 numbers in there that add together so that it all adds up to 1, because even that would get you one of these 2 marks here. So always make sure that they add together to make 1. Even if you're not quite sure, it's better to put something and have a go than to put nothing. But in this case, it was the same number in both of them. Right, it then says that there are 12 blue cubes. So we now know that 0.2 equals 12. The probability is 0.2, and that makes 12. Now 0.2, how could we write that another way? Well, we could say 0.2 is the same as 20%. So 20% is 12. Now if 20% of the cubes in the box is 12, 10% would be 6. And so 100%, we could just multiply that bit by 10. And that is 60. Or you could say, okay, if 0.2 is 12, then 0.4 would be 24, and you could keep going. 0.6 is 36, 0.8 is 48, and 1 whole, all of the counters in the box, would add up to 60. Or you could do 0.2 times 5 is 1, so 12 times 5 is 60. Loads of different ways of working around it, but yeah, that's how I would do it. You could also say if 0.2 is 12, 0.05, dividing that by 4 is 3, and then you could say, well, that means that there is, you could times that by 8 to get the number of red and the number of yellow. So that would be 24, add 24, add the 12 is 60. So lots of different ways of doing it, but if you got 60 on the answer line, that would give you both marks. Question number 23. Dion needs 50 grams of sugar to make 15 biscuits. She also needs 3 times as much flour as sugar and 2 times as much butter as sugar. Dion is going to make 60 biscuits. Work out the amount of flour that she needs. So to make 15 biscuits, let's put 15 biscuits here. She needs 50 grams of sugar. She needs 3 times as much flour, so that would be 50 times 3, which is 150 grams of flour, and she needs 2 times as much butter as sugar, so that would be 100 grams of butter. But remember, that's only 15 biscuits, and she's trying to make 60 biscuits. So we need to take those amounts and times them by 4, because 15 biscuits times 4 would make 60 biscuits. So we're actually only interested in flour for this question. So we're going to times the amount of flour by 4, and that would be 150 times by 4. 4 times 0 is 0, 4 times 5 is 20, 4 times 1 is 4, add the 2 is 6. So that would be 600 grams of flour. And we can do the other two as well. If we times 50 by 4, we get 200 grams of sugar. And if we times the bottom one, the butter, by 4, we get 400 grams of butter. But the question was only asking us for the flour, so she needs 600 grams of flour for the question. For the biscuits, sorry. Dion has to buy all the butter she needs to make 60 biscuits. She buys the butter in 250 gram packs. How many packs of butter does Dion need to buy? Now, if we're looking at the butter, we already know for her 60 biscuits, she needs 400 grams of butter. Now, she can only buy it in 250 gram packs, so 250 is not going to be enough. When she buys another pack, we get 500, and that is enough. So we're going to say that she needs 2 packs. Question 24, find the highest common factor, HCF, of 72 and 90. So there's 2 different ways of doing this. You could just list all the factors of 72. So you could say, well, 72, you've got 1 and 72, you've got 2 and 36. These are all numbers that go into 72 an exact number of times, and you're looking for the highest factor that they have in common that's in both the 72 list and in the 90 list. Problem with that method is you might miss one. It's kind of, you've just got to really know your times tables very confidently, and also sometimes they do ask you to do the prime factorisation first, so I think it's really beneficial to do it the prime factorisation way and just know that method. So 72, we're going to do the prime factorisation, is 2 times 36, and it doesn't matter what numbers you pick to multiply together as long as you keep going. Now, if they're prime, you're going to circle them. So 2 is a prime number because it's got 2 factors, 1 and 2. Nothing else goes into it. So 36, I'm going to do 3 times 12, and 3 is prime, so we circle it. And 12 is 3 times 4. You could do 2 times 6. It doesn't matter. You're going to circle any prime numbers and keep going until you've circled all of the numbers that are coming off. You never do 1 in itself. You just do other things that go in. So we've got 2 times 2 times 3 times 3 times 2. 2 times 2 times 2 times 3 times 3. And that should make 72 if we did that sum. I'm now going to do the same for 90. And 90 is 9 times 10. 9 is 3 times 3. And 10 is 2 times 5. So that is 2 times 3 times 3 times 5. And then we're going to put that information in a Venn diagram. So this circle is for 72, and this circle is for 90. And if they're in both lists, you can put them in the middle. So we've got 2 and a 2, that goes in the middle. You've got 3 and a 3, that can go in the middle. You've got another 3 and another 3, so we can put another 3 in the middle. And notice I'm only putting it in the middle once if it's on both. And then I've got 5s left over here, but no 5s on the other number. And I've got a 2 and a 2 left on these that can't go in the middle. So now this circle is complete. It makes the numbers I had here. And this circle is complete and it makes the numbers I had here. If we've got numbers in the middle, we times those together to get the highest common factor. So the HCF is 2 times 3 times 3. 2 times 3 is 6, times that by 3, and that is 18. So 18 is the highest common factor, and hopefully that makes sense because you might not have known that that went into 90 an exact number of times, and you might not have known that that went into 72 an exact number of times, but that method has led us right to it. So that is 18. This part is called the prime factorisation, or writing it as the product of its primes, and then we've drawn a Venn diagram to work out the highest common factor. And just multiplied the numbers in the middle together, what fits into both. Okay, question 25. The diagram shows the plan, front elevation and side elevation of a solid shape, drawn on a centimetre grid. So the plan is just the view from the top. View from above. So that's what the shape looks like from above. The front elevation, as it says, is the view from the front, and the side elevation is the view from the side. So this is a shape that looks like a circle when you look down from above, and from the front it just looks like a rectangle, and from the side it looks like a rectangle. It says in the space below, draw a sketch of the solid shape and give the dimensions. So that just means say how big it is. So hopefully it will make sense if I say that this is a cylinder, so like a tin of baked beans or whatever. We've got a circle on the top, and from the front it just looks like a, please excuse my dodgy drawing. There we go, that's not too bad. So we've drawn a cylinder, and it is, how tall is it? Well, let's have a look. From the front we can see that it is 5 squares tall. So it says it's on centimetre paper, so 5 centimetres tall. How wide is it? Well, for that we're going to need to look at the circle, and we can see that going across it has a width of 4 centimetres. So that's it. We've drawn it, we've given the dimensions, and that would be 2 marks. Okay, question 26, we've got this graph. It says shape A can be transformed to shape B by a reflection in the x-axis followed by a translation. Find the value of C and D. So a reflection is when you have a mirror line and you just reflect it across, and a translation is when you move the shape. The top number tells you how much left or right to move it, and the bottom number tells you how much to move it up or down. Now I would make a note of this. Left is negative and right is positive, up is positive and down is negative. So that's what I always make my students draw in their books. So first we're going to do a reflection in the x-axis. The x-axis is this line here. We can see it's got an x at the end. So that is my x-axis. I'm going to reflect shape A in that mirror line. So first we're going to look how far away from the mirror line it is, and we're going to make sure our reflection stays the same amount away. So it's 2 squares up from the mirror line, so it's going to go 2 squares down from the mirror line, and that line there is going to be reflected. This line here has reflected to that. And then we've got it going 3 straight up here, so it would go 3 straight down here, and then do any diagonal lines at the end. It's just easier. Join it up like that. So first it's reflected and it goes to there. Great. It's then translated by our vector to get across to shape B here. Now when you are counting squares on a graph, always start, pick a corner and count. Don't count the whole squares because that's when people go wrong. You want to count the corners. So we want to go 1, 2, 3, 4, 5, 6. And then it's gone down 1 as well. Now I am going to the same corner on the other shape. It wouldn't matter if you picked this one, it's still 1, 2, 3, 4, 5, 6 and down 1 because you're going to the same point on the other shape. So it's gone 6 to the left and down 1. Now we said to go left it would be the top number, and left is negative. So that would be -6. That would tell me to go 6 left. The bottom number tells us up or down, and it went down 1, which would be -1. If it was +1, then it would just go up, or 1, it would go up. So C is -6 and D is -1. Okay, question 27. A shop sells packs of black pens, packs of red pens and packs of green pens. There are 2 pens in each pack of black pens, and there are 5 pens in each pack of red pens, 6 pens in each pack of green pens. On Monday, the number of packs of black pens sold to the number of packs of red pens sold to the number of packs of green pens sold was in the ratio 7 to 3 to 4. A total of 212 pens were sold. Work out the number of green pens sold. So there are 2 pens in each pack of black pens. So the ratio is 7 to 3 to 4, but that's talking about packs. Okay, so we need to say, right, well, every pack had 2 in it. So this ratio would become 7 times 2, because there's 2 pens in every pack. So the ratio of the number of pens is 14. Now, that was for black pens. The middle one is for red pens, and every pack of red pens has 5 pens in it. So we're going to times that section by 5. So now what we're getting is we're getting the ratio of pens. So 14 pens were black to 15 pens being red. Might not be the number of pens, but it's the ratio of the number of pens rather than the ratio of the number of packs. Green, there's 6 in every pack. So 4 times 6 is 24. So now, oh, that's green, sorry. So now we've got 14 to 15 to 24 as our ratio of the number of pens. And we know that in total there were 212 pens sold. 14 add 15, add 24. Now normally when I do ratio, I do little lines. So I do 14 little lines for the first section, and then I do 15 little lines for the second section, and so on. But that's going to be quite difficult to do because these numbers are quite big. So I'm going to do 14, add 15, add 24. Now that's 29 for those two. Add 24, which is 53. Now, if I do 212 pens divided by 53, you can just count up for this. 53, 106, 159, and then if you add on another 53, you get to 212. So that fits in 4 times. And that means that we need to times each of these numbers by 4. So 14 times by 4 is 40, add 16, so 56. 15 times 4 is 60. And 24 times 4 is 96. And hopefully those three add up to 212. Let's just check. 96, add 60, add 56. 6 add 6 is 12, carry the 1. And then we've got 9, add 6, which is 15. Add the 5 is 20, add the 1 is 21. So yeah, 212. So then we've got our number of pens, work out the number of green pens sold, and that's just that final number there because it was in the ratio for black to red to green. So 96 is our answer. Really quite tricky, that question. You could have just kept multiplying this until you got it added up to 212, but that's probably the best way of doing it. So well done if you got that. Here are 2 rectangles. ABCD is the first rectangle and PQRS is the second rectangle. It says QR is 10 centimetres. So the first thing I would do is I would write that on. Whenever they give you any information, you want to put it on the diagram because it just makes it easier to see. It says that BC is the same as PQ. So let's just call this X. And if this one's X, this one is also X. They've told us that they're the same. We don't know how long it is, but we know it's X. It then says the perimeter of ABCD is 26 and the area of PQRS is 45. So I know that the lengths on this rectangle add up to 26. The top side, add the bottom, add the other side. All 4 sides add up to 26. And this rectangle has an area of 45. So that means that the base times the height equals 45. Now, I don't know the base. I know it's X, whatever, top one, bottom one are the same. So something times by 10 equals 45. How would I work out that missing length? We would need to work backwards and divide by 10. So 45 divided by 10 is 4.5. So now if I make this 4.5, I know that this rectangle has an area of 45. If that one's 4.5, however, this one is also 4.5. And that means that this one is also 4.5 because they're rectangles and the opposite sides are the same length. So now I know that 4 add 4.5, add another 4.5, that is 9. So far the perimeter of this rectangle is 9, but they've told me the perimeter altogether is 26. So what would I need to add to 26? What would I need to add to 9, to get 26? 26, take away 9. If there's more on the floor, borrow from next door. 16, take away 9 is 7, and then we've got 1, take away nothing. So that's 17. 17 add 9 is 26. So I need these 2 sides together to make 17. And they're both the same, so we can do 17 divided by 2. How many 2's go into 1? Well, it doesn't. How many 2's go into 17? It goes 8 whole times, remainder 1. Now, if there's nowhere to put that remainder, just put a 0.0. And then 2 into 10 goes 5 times. So it is 8.5. That makes sense. We've got 8.5 here and 8.5 here. So the length of AB is 8.5. Here is the graph of y equals x squared minus 2x minus 3. So the x squared tells us that this is a quadratic, and that means it makes this parabola shape, this U shape. Sometimes it's this way, sometimes it's this way. It depends if the x squared has a positive or a negative in front of it, but because it's positive in this case, it's going to be a smiley face this way up. So we've got that on the graph. It then says write down the coordinates of the turning point. Now the turning point is quite simply the place where the quadratic turns. So it is turning here. What is the coordinate of that point? Now I think everyone could probably have a guess at this question. What's really important is that we remember that coordinates go along the corridor and then up or down the stairs. So we're going across to 1 first. We're looking at the x coordinate first, and that is 1. And then we're going down to -4. Here. So the coordinate is 1 minus 4, the x coordinate is 1, the y coordinate is -4. 1 mark for that. Then it says use the graph to find the roots of the equation x squared minus 2x minus 3. Now that's what we've got on the graph. That's what's drawn. Y equals x squared minus 2x minus 3. But they want to know, when does the quadratic, when does the parabola equal 0? And it equals 0 along the x-axis. So these, where it crosses that blue line there, that is where it equals 0. Those are the roots or the solutions of this. So it equals 0 at 3, and it also equals 0 at -1. So you might have one solution if it just came down, touched the x-axis and went back up, but most of the time you're probably going to see that there's 2. So the answer for that would be -1 or 3. And that was the last question on the paper. So there we go, 80 marks. Let me know how you did in the comments. It'd be great to hear from you, and let me know what you'd like me to film for you next. Thanks for watching.